Hi, my name is Santosh Chelvaraju. So today I'm going to talk about my project, Scalable End-to-End Machine Learning Data Pipeline with Kafka. So this is my big data technologies project for this semester. So coming to the introduction, why am I calling it Scalable Machine Learning Data Pipeline is because we are using Kafka streams here. Since we are using Kafka streams, we can scale the streams to any to the extent that we need. We can have multiple streams with multiple topics, and this is very convenient when we have to differentiate between the type of messages and differentiate between different subscribers. So in this project I'm going to basically build a machine learning model, and I'm going to put the uh, predictors that I need for prediction and as messages, and on the other end I'm going to read these messages, and I'm going to use the model to predict the response. So coming to the architecture, so the data set that I'm going to use for model training is stored in Hadoop file system, and the machine learning program, the Python program trains the model and splits, and here the data frames, the individual tuples or the predictor variables are fed in as messages into the stream, and on the other end, consumer gets the messages, uses the saved machine learning model, and prints the response prediction output on the console. So implementation. So these are the Python packages that I've used: Kafka, Python, Pandas, Scikit-learn, and PySpark. I've also installed Kafka on the AWS EMR cluster. So basically, I'll be running this application on AWS EMR, and so it's a master node EMR cluster. So this is basically a multi-threaded Python program, and here there are three main primary threads, and I have used a singleton design patterns across the program. So coming to the very first thread, ML model trainer thread. So in this thread I'm basically going to read the data set from Hadoop file system. The data set that I'm using here is Boston housing data set. I'm going to read the data set, I'm going to build the machine learning model, and I'm going to split the data set into test and train data set, and I'm going to build the model, and then the model is saved inside a ML model folder inside the source code directory. And once the throughout the course of training the model, so there are certain flags that I update, and it is based on these flags the other two threads operate. Assume the model is still being trained, and it is and you don't have anything to and there is no model for access to predict. So the other thread waits until a model is ready. So once the model is trained and is available, the other thread picks up the model and uses it for prediction. So this is the producer thread. So producer thread, since I've used singleton design pattern, so every thread class has access to every other thread class. So there is only one instance for every class. So the producer thread gets access to the test data frame, where the split data frame, the test data frame of the machine learning model trainer thread, and randomly picks individual tuples and sends it as messages into the Kafka stream, and under the topic sample. So why am I picking it as random? Because so this is basically a simulation POC kind of a project where we are trying to realize the scalable machine learning data pipeline. And for that, in that case, so I'm just trying to realize the idea, and I'm not particularly focusing on any problem statement. So I am going to push the messages into Kafka stream, and on the other hand I have the consumer thread basically gets the messages from the message stream, and it will load the machine learning model which was earlier saved by the other thread, that is the machine learning model trainer thread. Once the model is trained, it is going to once the model is available, so it's going to use the model to predict the response for the incoming messages from the stream. So let me give a quick demo. So let's go here. So so let me push the data set into HDFS, that is the boston.csv. So I push the data set. So once I push the data set, let me start the program. So let me clear it before that. So yeah. at the program. So as you can see here, the three threads have started here. So now the data is picked up and the model is being trained. And during this process, the other two threads are halted. They're waiting for the update. And now the model training success message came. And now the streaming starts and the prediction starts. So you can see here, this is the message sent message from the Kafka producer thread. So this is the got message from the Kafka consumer thread. This is the predictor variables for which the prediction has to be done. And this is the prediction which is done using the saved model. So this messages streaming and prediction continues over and over. And so I've in between every message that is put into the stream, I have put a sleep of 15 minutes, 15 seconds, just for the sake of readability while seeing the messages on the console. So I'll stop the program here. I'll just quickly walk you through the code. So this is the code base that I've uh, uh, written from scratch. So this is the three threads where I'm starting the this is where I start the three threads. So going to the model trainer thread. So this is where as you can see here, I'm using singleton design patterns. And this is where I read the data frame from the HDFS, and I'm going to split into test and train data set, and I'm building a linear regression model using the train data set, and I'm going to save the model. So once I save the model, I'm going to move the data set that I used for training this model to a different folder. Just since I've implemented a thread for model training, I would like to use it as an application, like where if I put in a new data set to the HDFS, the model trainer thread automatically picks it up, prepares the model, and saves the model. So, and going to the Kafka producer thread. So here in the Kafka producer thread, I take a random sample. As I said, this is just for the sake of simulation and realizing the scalable machine learning data pipeline idea. I'm taking the sample tuple and I'm going to send it as message. And so this is the message sent, which we saw on the console. And I'm putting a sleep of 15 seconds. As I said, this is just for the sake of readability. Coming to the consumer thread, so this is the consumer thread. So this is where I check the status is thread so this is where I check the is model trained status. If the model is not trained, if the model is not available, if I try to load the model, I'll get an exception. So to tackle this scenario, I've come up with this logic of maintaining the status across different stages of model training. So once the model is available, I'm going to get on with the consuming messages and prediction process. So this is where this is the message which is on the console. I got message. So before getting on with the production prediction of each message, I basically check whether there is a new model available. So whenever, and assume, as I said, when I suddenly put in a new data set, a new model will be available. So this flag will be set to true. So if that is set to true, the new model is loaded. So, and once the new model is loaded, it will get on with the usual prediction process. So this is the message that we saw predict for, and this is the prediction. So I'm storing all of the very commonly big strings constants inside global constants.py. So these are some of the paths where I access the data set, and other things where I save the model and all. So which I have put it as variables, which I'm going to access it across different threads. So this is the quick uh, walk through the code base, and let me go back to the demo. Coming to the future scope of the project, so the I think there is a broader scope of scaling for this project. It basically depends on the requirement and the problem statement. Because one of the major things that I would like to integrate further, which I had plans of integration, out of time constraint I could not do it. So I would like to integrate Redis to implement LRU caching mechanism. So LRU caching mechanism is basically going to help fetch the predictions super fast. When there is a higher throughput, there is a very high possibility of getting similar messages, also sometimes a pattern, messages of a particular pattern. So in that case, we can actually, instead of going to the model and getting the prediction out, we can probably get it from the LRU cache. So LRU cache basically helps in identifying the messages which have not been used for the longest amount of time. So in that way, we get the messages which have been frequently being used, and we can quickly get the predictions instead of going to the model. So so this is not the only way of building this application. There is a much better way using the Flask framework. And just like how I trained the model, here we can use the cron job to train the machine learning model, and REST APIs to push in the messages to the Kafka stream. And similarly, on the other end, consumer can read the messages and document it, or send the response back to the front end for putting it on the putting it on some website in case of web applications. So that is one of the future works for this project. Thank you so much.